We are now going to segue to our next discussion, which is building a standardized data pipeline from the cloud to all devices in the vehicle. And it is my pleasure to introduce Mark Singer and Shivangi Bhakat from ESync Alliance. Welcome, Mark and Shivangi.
Hello, Chris.
Thank you. And we're going to do the typical test here to see if we yet have control of the slides, which seems to be the case, not yet the case. There we go. So, thank you for joining our talk. The intention here, the ESync Alliance would like to present a working model for a single secure data pipeline to reach ECUs and smart sensors throughout the connected vehicle. And I'm Mark Singer. I head the marketing work group for the ESync Alliance. We are focused on the promotional aspects, the logo compliance program, member recruitment, and liaison marketing activities. And that's what brings me to our presentation today. And I'd also then like to introduce Shivangi Bhakat from the technical work group. Shivangi is co-chair of our technical work group. Shivangi, would you like to say hello?
Sure. Thank you, Mark. Hello, everybody. I'm Shivangi Bhakat. I'm the vice chair of the ESync Alliance's technical work group. I've been the vice chair since its inception, so it's been an honor. I work for Alps Alpine of North America here in Michigan. Pleased to meet you all. My responsibilities as far as the technical work group are concerned, I run the work group meetings for the Alliance that occur on a weekly basis, and we have participants from each member company joining these meetings. Our notable output as the technical work group so far has been releasing the first version of the ESync Alliance specification, and we're currently working hard to release the second one by the end of the year. Thank you.
All right. So we've heard in a couple of other presentations prior to this some of the challenges in the automotive OTA arena. We might sum that up as being kind of an X by Y matrix. We have many technology providers in the automotive arena, and we have many large automakers in the automotive arena. Between these, we wind up with a very complex matrix of OTA schema. We have at least 8 different vendors who provide proprietary OTA approaches. We have 4 different operating systems with proprietary or OS unique OTA approaches. And we have, among the large automakers, at least 6 who are pursuing their own proprietary approaches to OTA for their vehicles. Most of the initial OTA work was focused on IVI, as we heard earlier in presentations, but most software recall costs are actually powertrain or safety component related. And there's very little in the IVI domain to manage that process. There are a great variety of devices, processes, resources, operating systems, and networks within the typical car. And the pursuit of proprietary approaches has led to an explosion of complexity and cost on the OTA arena. And these are the factors and the forces that have led to the formation of the ESync Alliance. The model of the ESync Alliance is to create an open multi-company initiative to standardize the OTA platform, and then to invite OEMs, cloud service providers, tier ones, technology providers to join together in implementing their pieces of this open, this standard. It is a 3-tier approach: server, client, and agent. Server in the cloud, client for the vehicle, and agents for the devices. And then the Alliance manages the process of specifications and compliance, Typical trade association activities, such as plug fests and the ESync compliant logo, and industry outreach and liaison with other organizations. So to give you a little bit of an understanding of ESync, a very simplified diagram of server client agent construct that we will provide progressively more information about. So we have the functionality of the server, the client, and the agent well defined in the specifications. It is multi-tiered in its structure and in its security. And the model is that ESync compliance is a combination of conforming to the architectural specification, the APIs between the levels of those architectural specifications, and the behavioral features, the specifications of each of the levels of the spec. And this kind of defines the process of determining ESync compliance so that servers, clients, and agents can come from different sources. And those who may already have existing solutions may bring those solutions into compliance with the ESync specification over time. So this is the model that the ESynC Alliance pursues for what is ESync. ESync is from the start intended to be something that is reduced to practice. So I do not want to infer that this is somehow a theoretical model. By the end of 2020, there will be 5 automakers worldwide in production with vehicles that use ESync for their OTA platform. And some of those automakers have now extended to multiple models. In fact, we have 2 different automakers that each have 3 models, either in production or coming down the pipeline, that use ESync to reach the devices in the vehicle. By the end of this year, we would expect more than 1 million cars on the roads with ESync, and the programs that are already committed will eventually lead to, we're anticipating something in the area of 10 million vehicles with ESync. So it is something that is and has been reduced to practice. The in-vehicle complexity, the ability to manage in-vehicle complexity is one of the key aspects of ESync. And some simple metrics on that. ESync is now already reaching more than 60 devices in a vehicle. The first vehicle to go to production had more than 30 devices that were reached by ESync. ESync is now reaching 7 domains within one vehicle. ESync is now reaching devices operating under 12 different operating systems in one vehicle. And ESync is reaching devices on 4 different networks or buses in one vehicle. So the model of reach within the vehicle is, again, a very practical and real capability of ESync. For those who have attended Genevieve events in the past, the ESync Alliance was on display at the Genevieve event at CES this past January. If you did get a chance to see us there, we had a working demonstration put together with components from 5 different members of the ESync Alliance. My company, XL4, providing the server in the cloud, Molex providing a telematics gateway, which hosted the client, Alpine providing a cockpit system with a head unit and instrument cluster. This was a hypervisor system running Android and QNX virtual machines. And then 2 AutoStar devices, one from Hella, a body control module, one from ZF, an airbag controller. These were on 2 different CAN buses operating at 2 different speeds. And during the demonstration showcase, we were doing over-the-air updates and data gathering from all of these devices. And that introduces the interesting potential of a bi-directional data pipeline, which is part of the ESync specification. And we encourage thinking about this as bidirectional because for data gathering, the process of over-the-air updating should be considered inherent to the process. That is to say, we use ESync to send the data gathering configuration to the devices to draw the data from those devices. And here we are speaking not just about DTCs or sniffing the bus, but we're talking about updating the devices to provide real-time operating data. And so things like memory health or internal operating temperatures or the voltages that are being seen by these devices, monitoring protocol errors on buses. These are all things that ESync provides the toolkit to do. And I'd like to explore that just a little bit more because it is, I think, an important concept for the dialogue between the ESync Alliance and Genevieve. So making use of this server client agent model with agents distributed throughout the vehicle for ECUs, high performance computing, smart sensors. I hope you will grant to me the OTA construct of installing some new software component to a device. When we start to ask the question of how data aggregation takes place, ESync then provides this working pipeline. Instead of sending a software update, ESync can send a diagnostic script to a device. ESync has short messaging capability, and so this can be used to provide command line interface to initiate the diagnostic script in a device to open up the data channel. And ESync provides in the new specifications multiple forms of data handling on the on the data pull side. And these can be short messages, bulk file transfers, streaming data. This can then be handed from the ESync pipeline to other sources, other destinations in the cloud, or it can be handed to other devices within the vehicle that may provide local storage, and then these devices could then condition that data before that data is sent to the cloud. This as a perhaps important step to managing what an earlier presenter described as the data tsunami, needing smart data perhaps more than big data. When you have 60, 80, 100 devices in a car generating data and 100,000 cars in the fleet from which you might be drawing data, it may be a critical consideration to manage how much of that data is sent to the cloud. ESync provides these mechanisms through the construct of the message broker within the ESync client. The message broker creates what we refer to as the ESync bus to talk to the agents, but that bus also talks to services of the client. For example, the HMI, monitoring of the vehicle status, monitoring of OTA success, and this same message broker interface can be used for corresponding with a data service, which then might have local storage. And this construct can all be done within the model of ESync compliance to make use of that ESync data pipeline. And when we look at the vehicle interface, the Common Vehicle Interface Initiative that is now such an important project of the Genevieve organization, we believe that the construction and presence and wide distribution of a bidirectional data pipeline can make a vital contribution to what's being done in the CVII initiative.
And this is an exciting opportunity, we believe, for the two organizations to work together to ensure that CVII has the mechanisms within the automotive industry, within vehicles already shipping and planned and being implemented for the future to do the value-added work that is the CVII initiative. So we encourage a collaborative model. We believe it brings technology advantages. A single pipeline for OTA and data gathering is a better security profile and it's a better
efficiency profile. The ESync pipeline is proven to cross operating systems and bus boundaries and proven to scale to any number of devices in the vehicle. There are great timeliness advantages because the data pipeline is already ready. It works, it's practical, it's complete, it's proven, it's flexible, it's reusable, and a growing number of tier ones are already integrating ESync agents for their devices. And we believe there will be great advantages to working together, to collaborating, to focus on core purpose on both sides, while leveraging the good work done by each. And we invite
Genevieve and the CVII team and all Genevieve work groups to participate and contribute to the evolution of the data pipeline. We have shared members who are already participating in this role. I would highlight that our co-chair of the technical working group, Shivangi, is from Alps Alpine, and Alps Alpine, of course, is an early and prominent member of Genevieve. And so we welcome this level of participation. That concludes the presentation, and we offer, if you would like more information, our Executive Director, Mike Gardner, is available
for contact, and we are available now for questions and answers.
Thank you, Mark. I do have a couple questions for you. When was the ESync Alliance originally formed?
The ESync Alliance,
as with most industry fora, took a little bit of time to get its legs under it. There were several months spent building the organizational construct. The bylaws were adopted by the 5 founding member companies in September of 2018. And Shivangi mentioned the first version of the specifications. Version 1.0 of the ESync specifications was released in March of 2019, so only about 6 months after founding. So some body of work had been done before the actual formal formation of the organization, but we trace its date to September of 2018.
Fantastic. Another question coming in. You had said there are multiple OEMs that are now producing cars that use ESync. When did the first vehicle with ESync enter into production?
The first vehicle to use ESync was the HS5 by FAW, and that car has more than 30 devices reached by ESync. It began production began in March, and first vehicle deliveries were in April of 2019. So now just more than a year and a half ago.
Okay. And what does the pipeline or plan look like the back of this year and going into 2021 for other partnership type work that you're involved in?
For other partnership type work that we're involved in, we reach out to the operating system groups and seek to encourage their collaboration in the ESync pipeline. Our feeling is that collaboration is a really important model, and building walled gardens is a useful approach for a medieval fortress, but not for a modern electronics system. And so our belief is that the differing operating systems should all be interested in working in a multi-operating system pipeline. So we offer that contact. The version 2.0 specification brings great increases in the amount of information on the data gathering side, which also provides engagement beyond the OTA angle and into cloud resource providers who are looking at the construct of public clouds or hybrid public-private clouds. And so there's a great deal of outreach going on in those areas as well.
In Mark or Shivangi, what would you describe as the ESync Alliance's position on a common vehicle data model? What does that look like?
I can offer an answer, Shivangi. I will invite you to respond as well. My outlook, we would greatly encourage a common vehicle data model. ESync will be, I would say, agnostic to the content and seek to provide the pipeline to move the data and build a common pipeline. But our general enthusiasm for standardization and for multi-vendor cooperation generally guides us towards being enthusiastic about a common vehicle data model.
Yeah, thanks, Mark. I would like to add my 2 cents to it as well. Definitely, I think coming from an automotive standpoint, and I work closely with the big 3 here in Detroit, a common data model would definitely be well received by not only the tier 1s, but also the automakers themselves, since it makes things a lot easier for them. And of course, as a member of the ESync Alliance and a part of the technical working group, as Mark said, we would definitely be, more than enthusiastic about, working towards one.
Thank you, Shivangi.
Thank you.
Well, we are out of time for this session, but I want to thank Mark, you and Shivangi both for your input for today's discussion. Very helpful. Any follow-up questions, please feel free to follow up with Mark and Shivangi offline. We are now at a point in our schedule, we're going to take a brief break. We will have a video from Tuxera. Please tune in for that. And if you haven't had a chance to do so, please take some time and visit the Geneva Demo Showcase, where we have many companies who would love to engage with you during the breaks and other time during today's programming. And we will be back in about 5-10 minutes. Thank you so much.
Thank you, Chris.